Hello everyone. We are the team conformed by Osvaldo, Hector, Alan, and Montserrat, and today we are going to be presenting data classification. So let's start. First, we are going to be classifying household with data from the Encuesta Nacional de Ingreso y Gasto de los Hogares. Here we can see our independent variables or X or regressors and our dependent variable Y. And in this case, we want to predict if the house is from a socioeconomic status equal to low or bajo. Here we can see our preprocessing function. In a few words, we selected only the columns that we are going to be using. We read the CSV, we deleted the NaN values, we divided the dataset in X and Y, and also we converted it to a suitable data type for our models. And last but not least, we divided the whole dataset into training and test sets. We implemented the classification algorithms using sklearn from the Python library. Here we can see that the user has the freedom to select any of the available models, which are naive Bayes, KNN, support vector machine, decision trees, and random forest. We are going to continue next with Monse's explanation.
For evaluating the metrics, we created this function which takes two parameters, the predicted values and the real values, the ones we use for testing. Then we compute the confusion matrix with those two values and we store that into these variables. Then we count all the truths and false and put that into these formulas to get the different metrics, which are precision, error rate, recall sensitivity, specificity, and accuracy. Finally, we put all of this into a dictionary and that's what we return. For a final function, we have the opportunity to choose between which algorithm you want to feed your data with. So here we'll make use of all the different functions we have already explained. Here we have the preprocessing, where we feed the model, and how we predict some of the values, and how we get the metrics using this function. At the end, you're going to get something like this. This is how it's going to look, the result. And you also get to choose between this table. It's a data frame where you can choose from 0 to 5 between all the different algorithms we used. The first classification algorithm we used is Bayes, which is a probabilistic classifier as we've seen in class. This is the implementation. We use scikit-learn, and here we're training the datasets and we are feeding it. And this is how the results turned out with this algorithm. You can see overall they're fairly good and most of them live in 0.7. The next classification algorithm we used was KNN, which is the one that tells you to which class your data belongs depending on how close is. And here's our implementation also in scikit-learn. And the metrics turned out just a little bit different. We have changes in sensitivity. It went from 0.7 to 0.5, and in specificity, it went from 0.7 to 0.8. Hector is going to explain the rest of the algorithms.
Thank you, Monse. Well, the next classification algorithm is support vector machines. Support vector machines are the set of supervisory learning methods used for classification, regression, and largest detection. So the objective is to find a hyperlane in an n-dimensional space where the letter n is the number of features that distinctly classify the data points. Well, our implementation is import the SVC from sklearn and init the class SVC with random state equal to 5, and the random state is control the pseudo-random's number generation for shuffling the data for probability estimate, and feed the data train and return SVM. So the evaluation metric of the support vector machine, these values. The next classification algorithm is decision trees. Decision trees are not parametric supervised learning method used for classification and regression. The goal is to create a model that predicts the value of the target variable by learning sample decision root inferred from the data features. So the implementation the same, import decision tree classifier from the sklearn. Init the class decision tree classifier with random states equal to 5, where The random state is control the randomness of the estimation, feed the data train, and return DT. The variation matrix of the dictionary tree are these values, precision and whatever. So the last classification algorithm is random forest. Random forest is a superciliary algorithm. The forest induced is an ensemble of the decision tree, usually trained with bagging method. The general idea of the bagging method is a combination of learning models increase the overall results. Implementation the same, import random forest classifier from the sklearn, init the class with n estimator that is the number of trees in the forest, random state, the same story, feed the data train, and return RF. So that is our evaluation matrix of random forest. So that's it for me, and let's continue with Alan.
And as you can see, we have a comparison table with all the metrics of interest. One of the most striking things is that naive Bayes has the lowest accuracy and the lowest precision of all the algorithms. Likewise, it also has the highest error rate of all, making it the one we would choose the least for this classification task. Now, with a change in the weight class, we could increase the recall and the sensitivity of the support vector machine, the decision tree, and the random forest algorithms, at the cost of all other metrics getting a little worse. And here I point out the error rate because even though it increased, that is not something desirable. And as a conclusion, we can say that the true to false ratio is 1 to 4, which causes an imbalance. But this imbalance in these algorithms can be mitigated by modifying and taking into account the class weight. Now, with this modification, the precision, the recall, and to a lesser extent the accuracy are affected. But this is good to us because in our case, we are more interested in having a good recall because we want to reduce the number of false negatives in the dataset. A false negative in our dataset is that we want to decrease the cases in which a low-income house is classified as a high-income house. And therefore, the other metrics are not that relevant for this purpose to us. So this is our conclusion or our presentation, and thanks for your attention.